Alright, in this video I'll be using a geoboard. What a geoboard is a pegboard that is used with strings and rubber bands to allow students and people who like to have fun with it to create various shapes and explore geometric principles. First thing I'm going to do is create a rectangle. So, 1, 2, 3, 4, 5 by 1, 2, 3, 4. Make it a rectangle. Alright, now the perimeter of this rectangle is 1, 2, 3, 4. You can count the number of pegs, the number of spaces to get your perimeter. You have 4 here, 5 here, 4 here, 5 here, which is a total of 18. The area of the rectangle is 4 times 5, which is 20. Now the last thing we want to do with this shape is we're going to make a triangle. Over this, that covers half of it. Now, there are a couple of different ways to get the area of the triangle. First, since obviously it covers half of the rectangle, so is half that of the rectangle, which would make it 10. This can also be expressed through the formula of a triangle's area, which is 1/2 base, which is 4, times the height, 5. So, half of 4, which is 2, times 5 makes 10. That's the area of the triangle. Alright, now we're going to clear the board. We're going to make a pentagon. There we go. 2, 3, 4. There we go. Now we've got a pentagon. Now, one of the things about pentagons is they can be divided into groups of triangles. The easiest way to do it is like this. First, you get a rectangle that goes from the bottom 2 points and intersects with the top 2 lines, forming 3 triangles on the outside. Then, make another triangle to bisect, to split the rectangle in half. Alright, for the last bit, we need to calculate the perimeter of the pentagon, which is a little hard to do because they don't have a calculator function that will show all the numbers, but with the Pythagorean theorem, I can still explain it. Now, the Pythagorean theorem states that the hypotenuse of a triangle, so in this case it'd be these diagonal sections, is equal to the square root of the sum of the square of the other 2 sides. Using that information, I can calculate exactly what the perimeter of this pentagon is. Now, starting off, we've got our basic 2 here. Pretty easy. Then for these 2 lines, see that our sides are 2 and 1. So we have 2 sides with a length that is the square root of 5. And here, you see that it goes 2 up and 2 over, which means that this is 2 times the square root of 8, which reduces to 2 times the square root of 2. Now I have 2 of these, which makes that 4 times the square root of 2. Put it all together, and the square root and the perimeter of this pentagon is 2 plus 2 times the square root of 5 plus 4 times the square root of 2.